Guys, welcome to my channel. In this video we will learn how to make a job recommendation system from scratch. We will make a job recommendation system website that will recommend job based on the job title. We will use cosine similarity to assign similar jobs. We will predict 5 similar jobs on the basis of job title. So this is going to be very interesting if you are a machine learning or AI enthusiast, and this will be a project that will shine your portfolio. So let's get started and let's see how we can make this project from scratch. So let's go to the project code, and this is the code of front end. I have made a website front end with the Streamlit library. Streamlit we use to make web templates or website front end. So I have made a job recommendation front end with the Streamlit. So let's run this. So this is the front end. Yeah, this is how it's look like, and this is the title and like job recommendation system, and this is showing that this system will predict 5 jobs based on the job title, and this is how it's look like. We can select job title from here. This is a drop down menu, and let's select one job title from here, like automation test engineer. Click on this button, get recommendations, and this is how it's recommending the jobs. Like we have selected automation test engineer, and it is predicting selenium test engineer, and also predicting company, employment type, location, and requirement is required skills. And this is the second job and third job, and this is predicting 5 jobs. So this is predicting well, and let's predict some more jobs like DevOps engineer. So this is also predicting jobs related to DevOps engineer, like system development engineer, DevOps engineer, senior DevOps engineer, and also showing other details like company, employment type. So this is how our recommendation system is working, and we can also change the website setting. Like we can change the themes, like we can change into light theme. This is how light theme looks like. This is the code. I have imported Streamlit, Pickle, and Pandas. In Pickle format, we have saved the similarity based model and the dataset. And this is the code for Streamlit and Markdown menu, and the front end design I have added here. So this is the basic code, and we can also change the design from here. So let's see the dataset now. I have downloaded this dataset from Kaggle website. Though this is the data about company, employment job status, and other details like job description. So we can also download this dataset from Kaggle website, and we have to do some data pre-processing before using this data. We cannot use this data directly. So we will do data pre-processing with pandas, and then we will use this data from our model. So this is the data, and so I have made a documentation about this project where I have discussed the step-by-step process with which we are going to do in this project. So let's read this documentation. And the first part is introduction. So in introduction, this is a job recommendation system, and this recommendation system works on machine learning model, that is cosine similarity. And this model take will predict or recommend job based on job company's name, job status, job description, job location, and skills. Then this is the introduction part. Then define the problem. This is also very important step, because it is very important to understand whether our project is applicable for real world problems or not. And this project is helpful for platforms like naukri.com or linkedin and job portals, and this is helpful for their users to get a recommended job based on their job preference. So this is the problem statement we are we are developing a system that is helpful for such platform, job portal platforms. And then data collection, I have collected the data from Kaggle website, and this is a free data we can use and we can download. Then the data exploration and visualization part. For data exploration and exploratory data analysis, we can make different plots, and we can make different dashboard or charts. But I have skipped this process in this video, but I will discuss this part in later videos. So we can also make a different graph with Python libraries like matplotlib and seaborn, but I have skipped this part in this video, but we will discuss this in later videos. And we can also use Power BI, Microsoft Excel to make a different graph and charts. Then uh, data pre-processing is also important step before making a machine learning model or train a machine learning model, because we have to filter the data. We cannot make a machine learning model on raw data. So in this process we have to remove the null values or handling the missing values or inconsistent entries, because we are dealing with the text data. So we need to remove the null values or duplicate values from our data set. Then feature engineering is the part where we have to select the features. Like in this project we have to select the features that are related to our project. Like for example, we cannot select the job id for our recommendation system, and we have to select job skills. Like job skills are more important than job id, because like in feature engineering we need to select the features. For example, job id, there are two columns, job id and job skills. So we need to identify which feature or which column is more important for our recommendation system. Like job skills column is more important than job id, so we have to drop the or delete the job id column. Because like job skills, like Python developer and Java developer, they have different skills. So job skills are important column. And we need to identify these columns in feature engineering section. Then NLP related tasks, we have to remove stop words, convert word into lowercase, and remove punctuation marks, converting word into stemming. This we will discuss in later this. And then model selection, we will select cosine similarity model for this, and we will discuss about this model later. And then model optimization, this is the future part, model optimization and deployment. So this is the document. Let's understand the code now. So I have opened Google Colab for this purpose. And then the first part is data exploration and visualization. As I told you earlier that we will not discuss about data exploration and EDA part in this video. Like we will not make a different graph or charts. So we will just analyze the dataset with pandas. I have imported pandas, and then read CSV. This is the path of CSV file, and then this is the dataset. Then the shape of the dataset, like our dataset contain 20,668 rows and 7 columns. Then we don't want duplicate value in our dataset, so with this function like df dot duplicated dot sum, so there is no duplicate values in our dataset. Then the count of job titles, like how many job titles in the dataset. So Java developer, there are 162 Java developers, and project manager, there are 138 project manager in the dataset. And then this is the function. With this function we can see the Java developer with all the other columns. Then this is the part of data pre-processing. In we have seen that what we will do in data pre-processing, like handling missing values or inconsistent values. So here first we will check the null values. So with this function df dot is null dot sum, so we can check null values with this function. So there are 49 null values in company column, and then there are some values in other columns also. So we have to drop these null values or drop or delete these null values. So with this function, like df dot drop in place equal to true. So we are dropping the null values from the dataset columns. Then our dataset doesn't contain any null values now. In place equal to true shows that we are dropping the null values and we don't need to store that in a new variable. These changes will happen only in this df variable. Then feature engineering part. In this we have to select the features or columns that are important for our dataset. Our dataset contains 7 columns, but I have selected only 6 columns. Like I have dropped job id because job id is not important for our model building or model training. And then I have stored these all the columns. I have combined all the columns data like job title, company, employment type, job status, job description, location, and skills. And then I have stored in a new column, that is job tags. So this is the new column. It will store all the data of these columns. And then this is how job tags zero index looks like. And this is the job title, then company address, company name, and job description. And these are the details stored in one column. All the columns merge in a single column. So this is how it's look like. This is the part of feature engineering. We have selected the features for our model building, and we have dropped one feature, one column, that is job id. So this is the part of feature engineering. Now we have these job tags. We have to pre-process these job tags with nltk. And nltk is used for natural language processing task. And first thing we do that we will remove the stop words from the data. Stop words we will remove because it will increase the data or text size, or it is not more informative, or it act as a noise. So these are stop words. I, me, myself, these are the stop words. So it will also, if we remove this, then our model processing time will be less. So we have to remove the stop words, then convert all the words into lowercase or similar cases. So we have to convert these text into similar case, like are showing in uppercase, lowercase. So python is a case sensitive language, so we have to convert these in one case, like I will convert in lowercase. And then we will remove the punctuation marks. Punctuation marks also not important for our data, and these are punctuation marks. We will remove these punctuation marks from the data set. And these text data contains um, so many punctuation marks, so we have to remove this also. Then stemming and lemmatization. Let's understand converting words into stemming. So let's understand stemming and lemmatization. These are two different things that we do in text normalization. Stemming and lemmatization are text normalization technique that reduce word to their base words, base forms. So we will reduce the complexity of the words, and we will reduce the size of the words by stemming and lemmatization. They are used in search engines and machine learning algorithm to improve text preprocessing and information retrieval. So stemming remove the last few character from a word and faster and simpler than lemmatization. So let's understand the example of stemming. And this is the example, like caring word convert into care, and care. And in lemmatization, caring convert into care. So this is the root word. And in lemmatization there is a meaning of the word, but in stemming there is no meaning or incorrect spelling in stemming. So there are some more example, like stemming would return dank and as dancer. So dancer will convert into dank in stemming. And in lemmatization, dancer convert into dance. So this is the root form or base form of the words. Like stemming is more faster and simpler than lemmatization, and lemmatization is more accurate and context relevant than stemming. So these are different between stemming and lemmatization. So here I will remove duplicate job title from the dataset. Like our dataset contains duplicated job titles. We have seen that there are 162 Java developers and 138 project managers in our dataset. This is the record. So we just want there will be only one Java developer and only one project manager. there will be only one job title should be in our data set. So let's do this. Mm, so with this function, there are 5426 duplicated job title in the dataset. So with this function df dot drop duplicates and subset equal to job title. So we are removing the duplicated job title from the dataset by subset equal to job title. This is the column name. Then with this function we can remove the duplicated jobs and then store in the new variable, that is data. Data is containing only 10,000 rows from the data set, and there is no duplicate values now, duplicate job titles. So this is how new data is look like. And then this function, we are cleaning the text data, we are cleaning these job text. With this function we are removing punctuation mark with regular expression, and then nltk dot word tokenize text dot lower. We are converting the text data into lowercase. And then stemming we will do with ps dot stem, and then we send all the text data in this function. So it will return the text into as removing the converting the stemming words. Then this is the new job text one, this is the new column that I will store all the data in new column. So we will identify the difference between previous text data and new data. So this function will take all the text data will go into this function, and then it will clean all the data, and it will clean all the text data. So let's run this, and here is the new column and here is the previous job tag column. So there is a difference between these columns, and let's print the zero index job tags one. So this is how pre-processed text data looks like, and here we can see the all the text data converted into lowercase, and there is no punctuation mark, no stop words in this data. And this is also converted into stemming. So we cannot identify, this is not a regular English words or correct grammar words. So this is how pre-processed text data looks like, and this is ready for making our model or training model. So let's understand the vectorization part of words or text. So I have imported sklearn.matrix pairwise and cosine similarity, and then feature extraction.text import count vectorizer. Count vectorizer we will use to count the unique words in the text or paragraph. So we will count unique words in the paragraph. So let's understand from the documentation of sklearn about count vectorization. So this is the documentation, and we have an example. So let's understand this example. I have copied that code from sklearn, and let's understand from this example how count vectorization exactly working. So they have created a corpus. In that corpus there are 4 sentences, and then vectorizer equal to count vectorizer, and they have made a variable name count vectorizer, and then x equal to count vectorizer dot fit transform, and then fit this corpus of sentences, then print the vectorizer dot get features name out, and this is the print statement. This is showing the unique words in these corpus sentences. These are the unique words in this corpus. There are total nine unique words in this corpus. And then this matrix, this is a matrix or array. These are 9 rows, 4 rows and 9 columns in this matrix, and these 4 rows representing these 4 sentences, and these 9 rows representing these 9 unique words. And let's understand this matrix. So this 0 representing this end, and this 0 coming that, and this first in this first sentence there is no end in the first sentence. So this 0 is representing end is not coming in this first sentence. And then one is representing document. So document is coming in one time, single time in the first sentence, so there is one. And then the second sentence, this is representing the second sentence, this second matrix, this second array is representing the second sentence. So this 0 is representing end, So end is also not present in the second sentence, so there is 0. And then document is coming two times in the second sentence, so there is a 2. And then rest all the words. So this is how this matrix form. So here I have taken maximum feature equal to 10,000 and stop word equal to English. We can also remove the stop word by typing stop word equal to English here. And then max features equal to 10,000. We are taking 10,000 text from the data. We are not taking all the values from the data set, because it will take time to train and it will take time to convert into vector. And then cv2.fit transform data job text to list. We have convert this into vectors. And then vectors.shape, this is the shape of the vector, like 10,000 rows and 10,000 columns. And cv2.get features name out, this is the features. We have already seen here that how it is converting the unique values from the text data. It is taking out the unique text from the dataset that we have seen. Then cosine similarity. So let's understand about cosine similarity from this document. And this is the formula of calculating cosine similarity between two vectors or two vectors, that is a and b. So this is the angle between a and b. And then this is the example, like deep learning can be hard and simple. These are two documents, these are two words, and they converted these into vector representation, like how many times deep learning come in the document 1 and document 2. So this is converting the count vectorization that we are also converting. So this is the vector representation of both the sentences. Then they put these values in this formula. With this formula they are calculating the similarity between these a and b vector, and the similarity score is 0.8%, which is 80%. So these sentences are 80% similar to each other. We can also see that there is only one word difference between these two sentences, like hard and simple. These are very similar sentences, and the score is also showing that these are 80% similar to each other. So this is what we are also using in our model, cosine similarity. Cosine similarity all help us to identify the job title based on similar job description skills and that we have made in job tags. So let's understand about this. So I have made a similarity variable. In that similarity variable of cosine similarity, and then put the all the vectors. Then similarity 0, this is the matrix of 0. And we can understand these by, like, this is the a job title, this is like a job title. If you want to find the similar job with these job titles, then with this function we can find. It will find out top 5 similar metrics or job title. So this is the similar job titles from the data. So this is the function that is what is this function doing. And then I have made a simple function that will take the job title as input, and then based on the job title it will recommend top 7 jobs based on their location. So this is job titles, it will recommend job titles, and then new line, and then location of the job. So this is how it is showing. Like I have given system engineer, senior system engineer, senior system text engineer, then it is the recommendation of the model. So this is the basic function, and then I have fun- stored this similarity matrix in pickle format. So save this model in pickle format, like job recom dot pickle. And then the similarity matrix here, job, this is the similarity matrix, and this is the data, this is data, and then the similarity matrix. So this is our model completed, and we have saved our model in the pickle format. That's it from this video, guys. If you learned something new from this video, then don't forget to like, share and subscribe to my channel. Thank you.